Hello everyone, welcome on our YouTube channel Physics Made Easy Kota. This is the third part of the chapter Moving Charges and Magnetism. In this part we are going to discuss about the moving coil galvanometer, that we are going to understand what is moving coil galvanometer, its principle, construction, theory and the working of the moving coil galvanometer. Moving coil galvanometer is a device. This device is used to detect or measure small electric current flowing in the electric circuit. Now the question comes to our mind that what is the principle of moving coil galvanometer, which means that how this device is working. In actual, this device is based on the nature of the magnetic field. That is, when a current carrying loop or a coil placed in a uniform magnetic field, it experiences a torque. Moving coil galvanometer are of two types. First one is known as a suspended type moving coil galvanometer, and a second one is known as a pivoter type moving coil galvanometer. So firstly we are going to study about the suspended type moving coil galvanometer. For this type of the galvanometer, we are going to understand its basic construction, that how it is constructed, what is the role of the magnetic field here. As we can see that there are the two concave shaped poles of a permanent magnet. These magnets are used to provide the radial magnetic field. There is a one coil which is wound on the non-metallic frame. So now we can clearly see in this picture there are the two permanent magnets, north south pole. They are the concave pole pieces, and also there is a coil that is labeled as a C. It is bound on a non-metallic frame, and this coil is suspended with the help of the torsion head. And we can also see that there is a plain circular mirror, and this mirror is attached on the wire to note the deflection of the coil using the lamp and the screw arrangement. There are the two terminals that are known as the screw heads, and the wire is connected to these terminals. Also you can see that there is a spring, and this spring is connected to one of the terminal, that is also known as a screw head. This spring exerts a very small restoring torque on the coil. Also there is a soft iron core which is placed within the frame of the coil. This whole system is finally enclosed in a non-metallic, we can say as a wooden piece, to avoid disturbance due to air. So the next one is a moving coil galvanometer, which is of the pivoter type. So I am going to explain the different parts of this type of the galvanometer. So you can clearly observe that there is a soft iron core, and also there is a coil shown in the diagram. This is a coil of the copper, and this coil is bound on a cylindrical soft iron core, and this coil is pivoted in a uniform radial magnetic field provided by the two permanent magnets, and these permanent magnets are of the shape of the concave. And finally the coil rotates freely about the pivot. A light pointer is also attached to the coil. This pointer moves on a scale. A spring is attached to the coil to provide a restoring torque to the coil. There is a uniform magnetic field, but this magnetic field is always radial in nature. So what is the role or what is the meaning of the radial magnetic field? A radial magnetic field is always parallel to the plane of the coil, and it is produced by the concave shaped poles of a permanent magnet. So now to understand or to know the concept how the principle is applicable on this device, we assume few mathematical practical terms, let us suppose that capital B represents the intensity of the magnetic field applied to the device. I must be the current flowing through the coil. Of course, the coil has some length or the breadth, so capital A represents the area of the coil. If we give the turns to the coil, then of course there are a large number of the turns, and that turns are represented by the capital N, that represent the number of turns in the coil. So as per the principle, when current flows through the coil, it experiences a torque. So the tau is given by NIAB sine theta. So what is theta here? Theta is the angle made by the normal to the plane of the coil with the direction of the magnetic field, and here is the role of the radial magnetic field, and this radial magnetic field makes the plane of coil always parallel to the direction of the magnetic field. So in this case theta is equal to 90 degree. So the final answer for the torque is NIAB, and this torque is also known as the deflecting torque because it deflects the coil, and it is constant in any position of the coil under the effect of radial magnetic field only. So what about the uses, that why there is a need to create this device? The first use is clear to every one of us, that it is used to detect a small electric current in a circuit. Also this device is easily convertible, like it is converted to an ammeter by connecting a low resistor parallel to it to measure electric current. It is also converted to voltmeter by connecting a high resistor but in a series combination when it to measure voltage across the circuit. It is also used as a ohmmeter by making special arrangements to measure resistance. So this is for about the moving coil galvanometer, and we can see you in the next video lecture regarding the chapters or the concepts of the physics. Thank you. Have a nice day.